Hi everyone. In this video, we are going to solve a problem of elementary structural analysis that was asked in May 2019 exam setting on question number 4. It is asking us to calculate the deflection at point C when a force of 18 kilonewton load is applied at node V. So for solving the problem using STAAD Pro, I have already loaded STAAD Pro in metric version, and then I need to click the node numbers. So node number for A would be 000, B would be 300, C would be 600, D would be 900, and node of E would be 9, comma 2, comma 0. And then I would like to turn on the front view of the workspace. For that, I do have a shortcut over here. You can turn it on by going to view and selecting this button over here. And then what I like to do is enter the node numbers. For that, let me minimize my equation. 1 would be connected to 2, 2 would be connected to 3, 3 would be connected to 4, and 4 would be connected to 5. And then go to properties, go to prismatic. What we used to do was go to rectangular section and we just enter a fictitious number over here. But since it is asking us to calculate the deflection, we can't do that. So we need to assign the proper value of EI that is given on the question. So for doing that, go to general, and then we need to enter the value of IZ, not IX, not IY. Be very careful about that. So for entering that, you can see the value of EI is given as 21,000. Then if I am assuming I will use a still section, then E would be 2 into 10 to the power 8. Then this means I should be EI upon E, which is equal to 21000 upon 2 into 10 to the power 8. If you press the calculator, the value of I should be 0.000105. Enter the value on IZ over here, 0.123105. Add. And for the cable, it has given the value of AE is 2000 kilonewton. And if you are using the same material, then E is again 2 into 10 to the power 8. Then your A would be AE upon E. So it should be equal to 2000 upon 2 into 10 to the power 8, which gives us 0.00001. So you need to enter this value on AX, not AY, not AJ. So close this tab over here. I will again minimize the equation. Go to prismatic, general. AX would be 0.12341. Click on add and click on close. Assign section number 1 to member 1, 2, 3. Click the section, click assign to edit list, press 1 space 2 space 3, click on assign, and then click section number 2, click assign to edit list, type number 4 over here, click on assign. You can see that the material assigned here is concrete. We have assumed our modulus of elasticity value is 2 into 10 to the power 8, so that we need to go to material, click still, click create, and change this to beam section and change E to 2E8. Click on OK, and then again click create cable section and click 2E8. Click OK, and then select your beam section, select assign to edit list, type 1 space 2 space 3 assign, select your cable section, select your assign to edit list, select 4, click on assign, and then go to specification. Here you need to define a number 4 section is cable. For doing that, go to beam and make sure your initial tension is 0. Just click on add and assign that to edit list, type number 4 over here, click on assign, and then click on support. You can see that there were in support at node number 1 and node number 5. So to do that, click create, click pinned, click add, and then click your support, click assign to edit list, type your node numbers, which are 1 and 5, click on assign, and then go to loading. Click your load case detail, click add, click loading type is dead or whichever you want, it does not matter. Click on add and close. Click your load case one, click on add, and we applied 18 kilonewton on node number 2. So click on nodal load. It is going on downward direction, which is negative Fy. So type negative 18 kilonewton. Click on add and close. So select your load, select assign to edit list, type node number 2 over here and click on assign, and then go to analysis button, click define commands, click add and close, and then click run. Save your structure, click go to post processing mode, done, apply OK. It already loads the displacement screen. So you can see that on node number 3, the displacement on vertical direction is 13 mm. So if you want that to be shown on the figure, just come over here, click annotate, click node, click go global Y because we are trying to see the displacement on Y direction. Click annotate, close. You can see that displacement on node number 3 is 13 mm on downward direction. So that's solution to 4a. And on 4b, it is asking if this 18 kilonewton load was applied on C, what would be the displacement on V? So there is one theorem called Maxwell law of reciprocal deflection. It says displacement on node 1 due to force applied at node 2 is equal to displacement on node 2 due to force applied at 1. So if 18 kilonewton load is applied at C, then deflection of B should also be 13 mm according to that theorem. And the name of theorem is again Maxwell law of reciprocal deflection. So that's the conclusion to our video. I will be back with another one. Thanks for watching.